Hello. In this function, I want to look at graphing polynomial functions, and I chose this cubic. F of x equals 8x to the third minus 6x squared minus 5x plus 3. I want to take you through the steps in graphing this function. Well, the two things we can do immediately would be to first find the y-intercept. Well, that's easy. If x is 0, y will be 3. So we've got the intercept here on the y-axis, 0, 3. The next thing let's look at the endpoint behavior of the function. As x goes toward negative infinity, this number is getting very large negatively, so the function is heading down toward negative infinity. As x goes toward positive infinity, this number is getting very large positively. Our function then is going up towards positive infinity. All righty. Now I want to look for the rational zeros, if you will, the x-intercepts. And since it's a third-degree polynomial, I know it has at least one real root, and then it must have either 3 reals or 1 real and 2 complex roots. If there is a complex root, we know its complex conjugate would also be a root. So this function has at least one x-intercept. Now, from the rational zero theorem, we know that any rational roots have to take the form p over q, where p would be a factor of the constant 3, and that would be plus or minus 1 or plus or minus 3. And q, the denominator, has to be a factor of 8. So it would either be plus or minus 1, 2, 4, or 8. Well, I say before we involve fractions, let's try something simple like plus or minus 1 as a 0. Let's try 1. Let's try 1. Loneliest number, so they say. Let's see if that's a 0. 8, negative 6, negative 5, and positive 3. We'll use synthetic division. Bring down the 8 times 1, add, times 1, add, times 1, add, and 0. Sure enough, 1 is a 0. I know then that x minus 1 is a factor, and 1 is a 0, or if you will, an x-intercept of our function. Knowing that, my function gives me a quadratic factor of 8x squared plus 2x minus 3. 8x squared plus 2x minus 3. Let's factor that. 8 times 3 is negative 24, and 2 factors of negative 24 that add to positive 2 would be positive 6 and negative 4. So we'll split this middle term, and that will give us 8x squared plus 6x negative 4x negative 3. We'll factor by grouping. Taking out a 2x will leave us with 4x plus 3, and taking out a negative 1 also leaves 4x plus 3, letting us take out 4x plus 3 and leaving 2x minus 1. Now I've got everything completely factored. That done, I can identify the other 2 zeros I have. So I've got factors x minus 1, 4x plus 3, and 2x minus 1. So I've got a 0 at 1/2 and another at negative 3/4. I'll go ahead and plot those on my graph. So I've got a 0 here at 1/2 and a 0 at negative 3/4. I've got a very good idea what this polynomial will do. It's coming up from negative infinity, crossing at negative 3/2, hitting a y-intercept, down to 1/2, back at 1, and it keeps going up toward positive infinity. So to confirm that, I'll set up an if table and analyze the behavior of this function over the 1, 2, 3, 4 intervals that the 3 zeros set up. So I want positive and where the function is negative. So I have the factors x minus 1, 4, x plus 3/4, 2, x minus 1/2. Again, I factored 4 out of 4x plus 3 and 2 out of 2x minus 1. Now my intervals would be x is less than negative 3/4, negative 3/4 is less than x is less than 1/2. 1/2 is less than x is less than 1, and x is greater than 1. Here we go. Now, for 4 and 2, these columns are always positive because these are positive constants. Now, keep in mind, if we had taken out a negative 4 or a negative 2, the column would be all negatives. All right, here we go. I'm subtracting 1. So I have negative, 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 and positive. Again, if I subtract 1, less than 0, less than negative 1/2, less than negative 1 3/4, greater than 0. Negatives and a positive. Here I'm going to add 3/4. So negative, positive, positive, positive. I add 3/4, less than 0, but 0 is less than, and these are positive. And then lastly, I subtract negative 1/2. Negative, negative, subtracting 1/2, positive, positive. So now I can determine the behavior of my function, the if tables. So the function, 3 negatives is negative, 2 negatives positive, 1 negative negative, all positives positive. So as I suspect, I'm able to get the sketch of my function. It's what I thought it would be doing. Increasing, decreasing, increasing. Negative, positive, negative, positive. Where I asked, where is the function negative? From negative infinity to negative 3/4. Again, from 1/2 to 1. Where is the function positive? From negative 3/4 to 1/2, 1 to positive infinity. So this if table now allows me to find where the function is positive and where it's negative. When you go on into calculus and you'll be looking at these functions, calculus will take it further. It will show you how to determine specifically where the function is increasing and decreasing. It will allow you to find out where the function is concave down and where the function is concave up. It will allow you to find the relative and extreme maximum minimum values of the function. I know this function has a relative maximum here and minimum here. So calculus will allow you to find the specific coordinates for these points. And when you're in calculus, you'll find that this if table process is a very helpful way in analyzing the functions you'll be looking to graph. Hope this helps you.